Yes, these are the two constant terms we arrived now. That is constant term C1 and C2. Having these two constant values, putting these values in the equation 1 and 2. What is the equation number 1? That is slope equation. What is the equation number 2? That is deflection equation. Putting these two constant values in those equations, slope equation and deflection equation, we will get these two new equations 3 and 4. Right? Okay, now substituting these constant values in equations 1 and 2, what we get? EI dy by dx minus wx squared by 2. Instead of C1, we put this value WL squared by 2. This is equation number 3. Right? Now, in deflection equation, putting these C1 and C2 values, that is EI y is equal to minus WX cube by 6 plus C1 value, that is WL squared by 2 x C1 x, is it not? So C1 is WL squared by 2 x minus C2. What is the value of C2? Minus WL cube by 3. So it is equation number 4. Okay. Right. Equation 3 and 4 are the generalized slope and deflection equation for the cantilever beam. Right. Suppose we want to find the maximum deflection and maximum slope, what do you have to do? You should put the x value as 0. Why x is equal to 0? Right. Here, you know, it is a cantilever beam, is it? No, it is end A and this is end B. End A is fixed, end B is free end, right? At end A, there is no slope and there is no deflection. That is, at x is equal to L, at x is equal to L, that is at A, deflection y is 0. Slope dy by dx is equal to 0. Already we discussed. But at the free end B, it will have maximum deflection, that is y max. So because of this downward load, the beam will bend more, is it not? At where? At free end. So you will get maximum deflection. At the same place, you will get maximum slope. Suppose if you want to draw a tangent to this curved shape, the angle between the original shape to the deflected shape is known as slope, is it not? Here you will have maximum slope theta max. At the same place you will have maximum deflection y max. That is where? At x is equal to 0. As I already told, this is the starting point. In the case of cantilever beam, starting point is free end, that is x is equal to 0 here. Here, what is that? X is equal to L. So, at the free end, x is equal to 0. So, if we put x is equal to 0 in the equations 3 and 4, we will get the corresponding y max and theta max. If you put x is equal to 0 in the slope equation, you will get theta max, maximum slope. If you put x is equal to 0 in the deflection equation, that is in equation 4, you will get maximum deflection. Alright. So maximum slope. On substituting x is equal to 0 in equation 3, you will get EI into dy by dx minus ws squared by 2 plus wl squared by 2. This is the equation number 3, is it not? Right. EI dy by dx maximum, that is putting x is equal to 0, this will be cancelled. Is it 0? It becomes 0. So I cancel this term and WL square by 2. Right? What is the dy by dx max? This is nothing but theta max. Is it not? So slope, maximum slope. Right? So theta max. This EI comes here. That is WL square by 2 EI. This is the maximum slope for the cantilever beam. Right? Similarly, maximum deflection on substituting x is equal to 0 in equation number 4. That is, what is the equation number 4? EIy minus wx cube by 6 plus WL square by 2x minus WL cube 3. This is the equation number 4. Is it now? Putting x is equal to 0, it becomes 0, and this also becomes 0. Is it now? So what is the remaining term? Minus WL cube by 3. So EI, it becomes y max because we putting x is equal to 0. So it becomes y max minus WL cube by 3. This EI comes here. So minus WL cube divided by 3i. This is the maximum deflection. What is the negative sign indicates? Negative sign indicates downward deflection. So because of this load, what will you have? You will have downward deflection. So this negative term indicates the deflection is downwards. So now you have theta max, that is maximum slope, deflection, maximum deflection, y max. Okay. So this is the derivation for the maximum slope and maximum deflection, and generalized equation for slope and deflection in the equation 3 and 4. Okay, right. Let me discuss the next class, the next problem, right?